Just like our bodies need doctor to monitor our health, machine also need a way to understand their condition. But unlike us, power electronics cannot talk. They fail silently. And as our world becomes electric with solar plants, EVs, charger and smart grid, silent failure can mean blackouts, downtime and expensive maintenance. So I asked a simple question. What if power converters could have a digital doctor, constantly watching its health, learning its behavior and catching issues early? So, hello everyone, I am Rituvic Pandey, PhD candidate in electrical engineering at IIT Jodhpur. And yes, the doctor is a digital twin, a virtual replica that mirrors the real system. Let me show you how this virtual doctor works. So this is the concept of digital twin of a proposed PV inverter system. So here we are having the hardware setup, which is having the PV emulator, 3-phase voltage source inverter, the FPGA board and the voltage and current sensors, PCC node and auto transformer, which is connected with the real grid. And further we are having the proposed optimization technique, which is the Coulomb's electromagnetic field optimization, which is used for the estimating the internal parameters. And then we are having the digital twin, which is replicating the hardware setup. So here we are having the solar PV array, DC link capacitor, inverter, ripple filters, AC sensors and 3-phase grid. Using this knowledge, the digital twin runs side by side with the real inverter, predicting how it should behave, almost like a digital heartbeat. And when we compare the real system with the digital one, they match extremely closely. That's how we know the twin understands the hardware. Now that we have trained a digital doctor, what it does next? It monitors the system stability and health, just like a doctor checking for early signs of illness. Now let's look at what I found. Now first we check whether the digital twin truly compare the system. These waveforms show real and hardware in one color and the twin in the other. They overlap almost perfectly. This confirms the high fidelity digital twin formation, as you can see here. And then slowly we age components, reducing inductance, increasing capacitor aging and adding switching degradation. The twin immediately notices the shift like a doctor spotting early symptoms. It detects how each component affects the system in real time. As you can see in the proportion matrix, all are showing the diagonal formation, which means the error is very less. And further, finally, stability, the stability monitoring. So here the conditions for the stability monitoring is if Vx is greater than 0 and V dot x is less than 0 or moving average is 0, then it will be stable. As you can see from this result, the derivative of the Vx is in the negative, the moving average is 0 and the flag 1 is showing the controller stability, which is showing at every 10 millisecond that the controller is stable, and the flag 2 is showing the system stability at every 20 millisecond. So think of it as a predicting a heart problem before the patient feels anything. So in this journey, from learning from patient's behavior to detecting aging to ensuring stability, the digital twins becomes a silent guardian of power converters. As we transition, our renewable and reliability is everything. This work moves power electronics from reactive maintenance to predictive intelligence. And you can see here the 3D figure which is showing the stability. This is the positive and this is negative, the V dot x. Just like our bodies have doctors, now our power systems do too. Thank you.